should be live right now. Okay, all right, we're live. Okay, so we're gonna get started in just a minute. I'll start off kind of by going over an overview of what we're going to be talking about today, and then I'll get into some more details. So, so for today's class, what we're going to start with is I'm going to talk about our assignment. So we have a new assignment. It's on Google Classroom. You can access it right now. That's due on Friday. I'll talk a little bit more about that in a minute. I just want to make sure that there's enough people on YouTube that I'm not just talking to just a few people. I want to talk to as many people as I can before I move on. So we're going to talk about the assignment, and then after that we're going to have a lesson. So we're going to be talking about multiplying. Let me make this a little bit bigger. Multiplying and dividing. Rational expressions. Okay. Yeah, so that's what we're going to do today. So I'll give you a little lesson, and then that will be followed by an example or two, examples, and then an exit slip. Awesome. So that's our plan for the day. Let me bring this down just a wee bit. Looks like a few more people are streaming in to YouTube, which is great. We can get started. So we'll talk about the assignment, then the lesson, and then some examples, and then an exit slip. And that's our plan for the day. So looks like we have just like 3 people on YouTube. So yeah, you know what? Why don't we just hold tight? Because I don't want too many people to miss this. Although I assume that if you're gonna come late to YouTube, then you might actually rewind a little bit and see the beginning. So if you're just tuning in now, maybe rewind a little bit, because or maybe I'll say that after the fact. No, you don't have to rewind. I haven't said anything super important yet. But when I'm finished talking about this, I'll make an announcement to rewind. Okay, assignment. So we have an assignment available. It is on Google Classroom. So the assignment is, like I said, it's on Google Classroom. So that's the assignment. It's all on radicals. There are 10 questions on radicals. One question, or I think maybe 2 questions were solving radicals, and that tends to be the challenging topic in radicals is to actually solve a radical equation. So yeah, it's due on Friday. Please make sure that you read all the instructions. So in particular, I want you to submit your work. Okay, so that could be a series of photographs that you took with your smartphone. I would prefer, like, the best case scenario, what makes me the most happy is a PDF. So a PDF is kind of where it's at. I'm thinking that hopefully by like the next assignment, this was assignment 3, by the way, maybe by assignment 4, maybe I can actually make PDFs mandatory, and I can give you a little lesson on how to make a PDF out of images. A PDF, just the software that I have, just marking up a PDF is much better than marking up a photograph. So yeah, please make a PDF. You can do this with Microsoft Word. You could do this with Google Docs. You could do this with Dropbox, like the mobile version of Dropbox. You can do this with OneDrive. Everybody here has a OneDrive account associated with their Winnipeg School Division email address. You could do this with, what else? You could do this for Google Drive. for Android. It doesn't work for iOS, but on Android, you can make a PDF just with the little camera on your smartphone. So there's lots and lots and lots of ways to make a PDF. I will still accept non-PDF versions, but by far PDF is my preferred document. Simply because it's easier to mark up and I can actually mark your work. So it's 10 questions. Shouldn't take too long. I'm hoping that the due date of Friday doesn't conflict with anyone. I think it should be more than enough time. That's 2 questions per day. Okay, so that's the assignment. Did that. Okay, now let's talk about multiplying and dividing rational expressions. Okay, so let me just zoom in again over here. That's better. Okay, so we're going to talk about multiplying and dividing rational expressions. Okay, so that's what we're going to do today. So I just want to recall a few facts. So let's recall a few things. So let's say that A, B, C and D are non-zero numbers. Okay, so they're non-zero numbers. So I'm kind of just telling you about a property of fractions. So I think the first time you would have been exposed to this fact is in grade 8. That is to say, this is on the grade 8 curriculum. So I'm hoping that this is review in some sense, but if it's not, like don't worry about it. But I am hoping that we do already know this. So if I had 2 fractions, a over b times c over d, if I multiply them together, it's really straightforward. It's way easier to multiply fractions than it is to add fractions, which maybe seems a little counterintuitive because typically you might think of multiplying as being more challenging than adding, like as a principle, right? Just, oh yeah, multiplying is it's like the hard version of adding, right? Well, for fractions, it's not so, because fractions work proportionally, and proportionally has everything to do with multiplication. So if I have this fraction, a over b times c over d, that's the same thing as, well, I just multiply the numerators together, and I multiply the denominators together, b times d. Okay? So I just multiply the numerators and I multiply the denominators and I'm done. And it's very straightforward. Similarly, if we divide 2 fractions, so if I were to have a over b divided by c over d, well, that's the same thing. That's the same thing as inverting the second fraction. So, well, I'll leave the first one alone, and I'll multiply the reciprocal of the second one. So remember, this is what we would call the reciprocal of c over d. Reciprocal just means upside down fraction. What if you have a plus x divided by b times c over d? Okay, I'll get to that question in just a second. Someone on YouTube asked a good question. I'll get to that in a second. So going back to this, if I was asked to divide a over b divided by c over d, well, that's the same thing as multiplying a over b times d over c, which, as we just learned from the last property, is a times d over b times c. Okay, so that's those are the 2 facts that we're going to use today. These are, like the core fundamental facts that are going to guide us throughout today's lesson. So, just addressing a question that was in the YouTube chat. What if we had something that looks like this? A plus x over b, something like this. Divided by b times c over d times c over d. And let me know if I'm misinterpreting your question. I know that it's hard to type math out with a traditional keyboard. So maybe you meant a plus x over b. I don't know, but I think this is what you meant. Well, in this case, it's the same thing. It really is the same thing. We just have to remember that with fractions, any fraction, you can think of the numerator as having brackets around it. Okay, so there's an order of operations that just naturally come out of just being a fraction. So the numerator, you can always just add brackets around the numerator and the denominator. I mean, you don't really need to right now, certainly not with the denominator. In any case, we would just proceed as if there were brackets around there. So this would be a plus x times c, and maybe I'll use a dot for multiplication here because we actually have the variable x, and the denominator would just be b times d, and here we would be able to use the distributive property to distribute that c throughout those brackets. So we would have a times c, or I'll just write ac, plus xc all over bd. Okay. 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 Okay, great. Yeah, so the first one is right. Okay, good. All right. Okay, where are we? Okay, so that's what we're doing. So, I mean, in a lot of ways, this example is pretty much like what we're doing, right? We're kind of using this as kind of our guide, and we're going to be replacing this a with not just numbers, but now a is going to be like an expression like x plus 2, right? And then maybe c could be like 3x squared plus 2x minus 1, right? In which case we would, we know how to multiply these, right? We would use the distributive property to multiply those together, right? So we'd have x times 3x squared, x times 2x, x times negative 1, and 2 times 3x squared, and 2 times 2x, etc., etc., etc. So that's what we're doing. So let's just jump right into some examples. And let's see here. Okay, let's see. Okay. Okay, let's just jump into something that's not too bad. Okay, so first of all, I think this is a good place to start. So we're gonna state all NPVs. Okay, so we're gonna state the non-permissible values of this expression, and this expression is going to have two products. It's a product. It's a product of rational functions. Product, of course, meaning we multiplied. Okay, so we're going to state all NPVs of this. I have x plus 1 over x squared minus 5x plus 6 times, and I'm going to use a dot for this multiplication, even though in the book they have an x. But I mean, if you really want to write multiplication, I know that some people like to write their x's like this, kind of like a fancy x, or sometimes people write their x's like this, like a backward C and a forward C, and if you do it just right, it looks kind of fancy. And then for multiplication, they do kind of like a big sort of like like it looks more like a cross than it does in X. So whatever, you can make it look however you want. I'm gonna use a dot. So that's the first rational expression. The next one is x minus 2 over x squared plus 5x plus 4. X squared plus 5x plus 4. Okay, so we're gonna state all NPVs here. So really what I'm doing is I'm looking for NPVs in this expression and this expression. Okay, so I've got a little bit of work to do, right? So you can see how this stuff kind of builds and builds and builds and builds, right? Like we first learned about factoring quadratics, like seems like months ago. Well, maybe I think it was over a month ago. And here we are, we're still doing it. This stuff doesn't go away. So it's important that if you're still struggling with factoring quadratics and trinomials and that kind of thing, let me know, and we'll take it from there, because it is really important that that you can do this. Okay, so let's see here. Let's factor this first one. I'm gonna factor this, and then I'm gonna factor this, and that will tell me the non-permissible values of both of these rational expressions. And then when we multiply them together, the NPVs are just all of the NPVs of the entire thing. So in this first case, I'm going to say that, well, okay, it looks like probably -2 and -3. So I've got x, this is x minus 2 and x minus 3, okay? And on the right, looks like x plus 4 and x plus 1. So I've got x plus 4 and x plus 1, okay? So I factored both denominators, and this is what I got, which tells me that the non-permissible values are, NPVs are, well, I've got, x can't be equal to 2, x can't be equal to 3, x can't be equal to -4, x can't be equal to -1. So these are all the non-permissible values. And in this case, I think that this is actually where the set notation comes in handy, because really, I think that if it was me just doing this by myself, I would tend to use the set notation, because it's kind of a big set. There's four elements in the set. That's what you call a member of a set, by the way. You call it an element. So there's 4 elements in this set, and those are them. And when I make sets, I always tend to write them from least to greatest, although that actually doesn't matter. Okay, so those are the non-permissible values. All right. So no matter what our function ends up being equal to, in the end, the non-permissible values are just all the non-permissible values in both expressions. Okay. Now let's simplify this. So let's do kind of like a part 2. So part 2 is simplify the above rational expression. Okay. Okay, so what I'm going to do is I'm going to go ahead and copy this and bring it down here. There you go. Okay, I'm going to copy this, and then I'm going to remember what the factor version of this is. So I've got x plus 1, that I can't factor. X minus 2, I can't factor that. Excuse me. And the denominators, what I'm looking at is this portion right here, because I already did this work. I already factored the denominators, so let's not do it again. Let's just copy what we already know. So I've got x minus 2, I've got x minus 3, I have x plus 4, and I've got x plus 1. Okay. So there you have it. So if we multiply these two things together, what we get is just the product of the numerators over the product of the denominators. So in other words, this is equal to x plus 1 times x plus 2 all over x minus 2, x minus 3, x plus 4, x plus 1. Okay? And I made a typo. That should be x minus 2, right? Because this is x minus 2. That's what that is. This is over here. There we go. And I just copied these guys down here and copied these guys down here. Okay? So now you can probably see that I've got some common factors. There's factors in the numerator that are the same as factors in the denominator. So I will cancel these guys out. X plus 1, x plus 1, x minus 2, x minus 2. Okay, and I'm going to show you a big mistake. This is a mistake that I see lots of people make. They say, okay, I canceled everything out. My answer is x minus 3 times x plus 4. Can you see what the mistake is? I bet you can probably see what the mistake is. What do you think the mistake is? Yeah, these are in the denominator. I'm dividing by these things. But people tend to make the mistake that, oh, I've got rid of the numerator, then the numerator just disappears. No, the numerator never disappears. We can always assume that we're multiplying by 1, right? You can multiply anything by 1. And, I mean, if you wanted to, you could say, oh, yeah, well, there's a 1 down here, and I'll cancel this one with that one. Sure, but here's another one, right? There's always going to be another 1 that you can have. There's infinite numbers of 1 that you can draw from. So, don't forget, this is 1 over x minus 3 times x plus 4. Now this is what we would say that this is factored form. It's factored form because it's factored. I've got these factors, right? This is a factor, this is a factor, okay? If you wanted to, you could write it in expanded form. So we would have that this is equal to 1 over, well, x squared, would that be plus x minus 12? Okay, that would be expanded form, okay? This is expanded form because I expanded this. This has been expanded, okay? So I've taken the two factors and I've multiplied them together, okay? So those are the two forms. If it asks you to leave it in factored form, leave it in factored form. Otherwise, expand it. If it doesn't say, it doesn't really matter. You can choose whichever form that you prefer, unless it asks you to write your solution in a specific form. Okay. Okay, I've got about 15 minutes left. Let's see what else we can do. Okay, so here's a question that I want you to do. I'm going to give you, I wonder, 8 minutes? 8 minutes is probably enough. Okay, so you try. I'll write you try. Okay, and I'll just use some of the language that you might come across. It isn't really, this isn't how I would phrase it, but sometimes it's important to see how other people might phrase something. So this is just using the language right out of a textbook. Determine the quotient, not quotient, the quotient, and determine, and identify, sounds so legit, identify any non-permissible values. In the textbook, they actually wrote non-permissible values. They spelled it all out. I'm going to call them NPVs of the variable. Sounds very formal, which is good. So we're going to determine the quotient and identify any non-permissible values of the variable in this expression right here. So x plus 3 over x minus 3 divided by x over 4x minus 12. Okay, so The one word that kind of stands out here to me is quotient. Quotient just means divide, right? Product means we multiply. Quotient means we divide, right? Divide. So obviously we have a division symbol here. So they're basically just saying do the division and simplify and tell us of any non-permissible values. Okay. Now I am anticipating a few sort of oversights. I can imagine that like there's a lot of opportunity to get this question wrong. In particular, when it comes to these guys right here, these non-permissible values. So you have to be very careful about this question. You have to think which values of x are going to give me a problem. And here's the thing, it doesn't matter whereabouts in your algebra that the NPVs can occur. So if you ever divide by 0 at any point in your algebra, like as you're simplifying this, if at any point you have to divide by 0, that's where you get a non-permissible value. So you have to think about all the work that you do. Every step of the way, you have to be thinking, does this give me a non-permissible value? Does this give me a non-permissible value? Can I get one here? Can I get one here? So you do have to take these things slowly. So don't rush. Don't rush. So I'm going to give you 8 minutes. 8 minutes starting now. Okay, I'll come check up on you in 8 minutes. Okay, I'm gonna cut us off. I think 5 minutes is probably long enough time. If you're not finished, don't feel bad. I just want to do something. Okay. Let's close this. Okay, let's talk about NPVs first. Okay. We're gonna see that as we progress with our algebra, more and more NPVs. Well, actually, I should just tell you straight up. We'll get an extra NPV as we do more algebra. Okay. So right off the hop, I see this NPV. So we would get that when x equals 3, we have a non-permissible value. So I'll just write NPVs. And also here we would get, so that would be x minus 3 over here, and then 4x minus 12, so that would be when x is equal to 3, right? So, oh, that's another, there you go. It's a double whammy, right? In both cases, when x is equal to 3, it's like a double NPV, right? It occurs twice. Okay, so you might say, okay, now I'm done with my non-permissible values. Now I'm going to rewrite this equation. I'm going to rewrite this equation and say that I'm going to take x plus 3 over x minus 3 and say that that's equal. Well, I'm gonna invert and multiply, right? Because that's what I do with dividing fractions, right? Or dividing rational expressions. I multiply by the reciprocal. So let's write the reciprocal. I get 4x minus 12 over, what did I say? X. There we go. Hey, look, there's another NPV. So this non-permissible value is that x equals 0, right? So x cannot be equal to 0 in this case either, okay? Because x appears in the denominator here. So that gives us an extra non-permissible value. And then we're left with x plus 3 over x minus 3. And actually, let's just write the whole thing out. Here, I'll write one big fraction. That's better. And I'm multiplying this guy with all of this, so I have to be using brackets. So I got 4x minus 12. And here, same with this, I've got x minus 3 times x. Okay. Now you might be tempted just to like multiply everything out, but don't quite do that yet. Let's keep factoring. Let's see if we can reduce, or not reduce, but let's see if we can factor these completely. So x plus 3, I can't factor that. That's just x plus 3. 4x minus 12, though, those are some big numbers, right? 4 and 12, and they have some common factors. They have the factor 4 in common. So I'm going to factor out a 4, and when I do that, I get x minus 3. And then the denominator looks like it stays the same. I've got x minus 3 times x. Okay? So everything in the numerator, all the things here, these are all factors of the numerator. And we have a couple factors in the denominator. And the one that they have in common is x minus 3. So there you have it. And let's write this one out. Here I'm going to put 4 in front. I'm going to say 4 times x plus 3 all over x. Okay? So there you have it. Are there any questions about that one at all, or are we good? Should I move on? Great. Okay. Okay. So I think what I'm going to do, I'm going to leave you with an exit slip now. So we did, just going back to our little plan, we did a little lesson here. Oops, let's do green. We talked about the assignment. By the way, I said I would say this. If you're watching now, make sure that you rewind the video if you missed the little blurb about the assignment. I talked a little bit about the assignment. Here's our little notes on the assignment. So please make sure that you are aware of the assignment and the due date and everything about it. It's right at the beginning of today's video. We did some examples. Okay. I did an example, you did an example. Now let's do an exit slip. Okay, so the exit slip for today is going to be the following. Exit slip, nice and big, here we go. Exit slip for today is, okay, I want you to identify all NPVs and simplify oh, look who's sneaking up on me. Uh-oh, really sneaky cat. Never would have seen her coming. Okay, back you go. Okay, so identify all non-permissible values and simplify this guy right here. I've got x minus 7 over, and now Goose is lying on top of my keyboard, messing things up, and lying on top of the textbook too. It's almost like she wants my attention. Okay, x minus 7 over x plus 4. Goose, that's exactly what I'm reading. It's almost like you know that. X minus 7 over x plus 4 divided by x squared minus 2x squared minus 2x minus 15 all over x squared minus x minus 20. Okay, so you may need to use Desmos to submit your answer. You don't have to, but you may find it easier to type it into Desmos, see if you can get Desmos to make it look nice, and then copy and paste it, just like last time. Okay, so that's your exit slip. Let's talk a little bit about homework. I'd like you to work on a few questions in the book for homework. What is it? 6.2, I think, is what we're on. 6.3, 6.2. Okay. Okay, so for homework, 6.2. So homework, section 6.2, and I want you to do 1, all, 2, all, 3. I know that this looks like a lot of work, but these first ones aren't actually too bad. Well, yeah. So I want you to do all of them. I'm gonna get you to do 4C. I'd like you to do okay, and let's do number 10. Okay, so that's your homework for today. If you're stuck with any of the homework, like I always say, don't hesitate to reach out and tell me that you're stuck, and we'll figure it out from there. Maybe I'll do some more examples in tomorrow's class. Tomorrow, I really would like to do 6.3. That would be super. That one might actually take 2 full classes to cover, because it is where things get a little more challenging. In any case, this is what we're going to end off with. So there's your exit slip, and then there's your homework to follow. So yeah, and don't forget to check the assignment on Google Classroom. And yeah, until next time, I'll talk to you guys, I guess, on Tuesday, tomorrow. Okay, and I'll give you one more little money shot of Goosey here. Say bye, Goosey. Bye-bye. Oh. Okay, see you later. Bye-bye. Bye-bye.